So we have a question that says we should evaluate whatever expression, trigonometric expression that is given to us. I hope you can see it on the screen. So what this question is asking of us is to evaluate this. So meaning that we should find the value of this trigonometric expression over here. It can be a single value, or it can be like a single trigonometric ratio. We don't know at this point. We just need to simplify to see what it gives us. But sometimes they can tell you that you should simplify to a single trigonometric ratio, the very same expression, because when you evaluate it, you'll end up getting like a trigonometric expression. But sometimes when it's evaluated, you can either get a value or a trigonometric expression. So when you see this type of questions, the first thing that you should do is to draw a Cartesian plane. And the Cartesian plane that you draw, it shouldn't be like the normal Cartesian plane that you draw, whereby you just draw the vertical axis and the horizontal axis. It should be the annotated Cartesian plane. You put your cast, you put your angles, and then you show, okay, if I'm moving in the counterclockwise direction, how are my angles? And if I move in the clockwise direction, how are my angles? So normally the way other people draw the Cartesian plane, they just draw the Cartesian plane and include angles, whereby now they are going in the counterclockwise direction, meaning that they are going in the anti-clockwise direction. But they forget that you can also go in the clockwise direction. And when you go in the clockwise direction, that's when your angles become negative. So in my Cartesian plane here, I just included going counterclockwise and going clockwise. I also included my cast, and then what you would normally see if you go in the counterclockwise direction, which is your 90 minus theta, 180 degrees minus theta, 180 degrees plus theta, 360 degrees minus theta. You will see later in the video why I included the angles when we move in the negative direction, which is the clockwise direction. So theta, you should always keep that in mind. Theta is an acute angle, meaning that it's an angle that is between 0 and 90 degrees. Please keep that in mind, because it's also going to help us in answering our questions. So now, when we evaluate, let us start by solving the question. So now we have -1. So you know that -1, you cannot do anything to it. It's just -1. So unless maybe we might need to change it to a trigonometric identity of some sort later. But then for now, we don't need to do anything to it. We just write it as is. So it's -1. And then we add to that. They say cos 180 degrees minus theta. So using your normal Cartesian plane, you know that 180 degrees minus theta is actually your second quadrant. And in your second quadrant, what's happening? Only sine is positive, meaning that all the other trigonometric ratios, they are negative. So cos 180 degrees minus theta, it lands in the second quadrant. And you know that in the second quadrant, only sine is positive. So meaning that all the other trigonometric ratios will be negative. So you'll end up having negative cos theta. Negative cos theta. And then you multiply that by sine theta minus 90 degrees. So remember I told you that theta is an acute angle. So with this type of, when they give you the question or a trigonometric expression in this form, and then now you're supposed to simplify it. So the way you would do it, instead of doing the mathematics manipulation whereby you take the negative out, because I know some people love doing that, but they actually end up getting lost in the mathematics part of it, like in terms of manipulating this, they end up doing it wrong, and then they get it wrong for no reason. So I'd advise you, if you get your expressions in this form, so what you do, remember I told you that theta is an angle that is between 0 and 90 degrees. It's an acute angle. So you can just take an acute angle between 0 and 90 degrees. And then let's say we take 45 degrees. So we'll just say, okay, it's sine 45 minus 90 degrees. Sine, 45 minus 90 degrees. So let us look inside our brackets. We have 45 minus 90. So that gives us negative 45. So now you go to your Cartesian plane. So now you see that is the reason why I included the negatives as well. So you see that, oh, I have sine negative 45. So meaning that it's between 0 and negative 90. So if it's between 0 and negative 90, that means I'm in the fourth quadrant. And you know that when you're in the fourth quadrant, what is happening to your sine? Sine will be negative, because in my fourth quadrant, all the other trig ratios except for cos are negative. So only cos will be positive, in the fourth quadrant. So this sine theta minus 90 degrees, it's supposed to be negative something. But because when you see 90 degrees, you're supposed to change the name. And the name that you're changing to should be a complementary function to whatever trigonometric ratio that you're given. So in this case, we have sine, and we know that the core function of sine, or it's cos. So theta minus 90 degrees, it lands us in the fourth quadrant. And you know that in the fourth quadrant, only cos is positive. And then we have sine of something that is in the fourth quadrant. So, and we also have a cofunction. So the cofunction of sine, it's cos. And then that means we'll have negative cos theta. Because remember, sine is negative here in the fourth quadrant, and then the cofunction of sine is cos. And then we divide by this. So now we have cos negative theta. Like I told you, it's negative theta, meaning you can just say theta is 45 degrees. So if theta is 45 degrees, where does that land you? It lands you in the fourth quadrant. And you know that it's cos of something negative. And then remember, when it's negative, theta, it's negative theta, it's between 0 and negative 90, and that is your fourth quadrant. And remember that in your fourth quadrant, what is happening? Your cos is positive. So this cos of negative theta, it's going to be cos theta. And then you multiply that by sine 90 degrees plus theta. Remember that your sine 90 degrees plus theta, this is sine 90 degrees plus theta, and that's actually your fourth quadrant. Sorry, not your fourth quadrant, that's actually your second quadrant. Because remember, 90 plus theta, if you take an angle, an acute angle, let's say 45, you'll get sine 90 plus 45, which is basically sine 135. And remember, 135 is between 90 and 180 degrees. So that is your second quadrant. And in your second quadrant, sine is positive. But in this case, remember, we are seeing 90. And when we see 90, we are supposed to change to a complementary function of whatever trigonometric ratio that is given to us. So we know that the complementary function of sine is cos. So sine 90 degrees plus theta, it's the second quadrant, and in the second quadrant, sine is positive. And then because we see the 90, we are changing to the complementary function, and that complementary function, it's cos. So we'll end up having cos theta. And then we multiply by tan squared 540 degrees plus theta, so that you can, to make your simplification, you can just write it as tan 540 degrees plus theta, and then we'll deal with it later. So you square it, because remember, it's squared. So now let's solve this. You'll have 1, negative 1, and then you'll have negative, negative, positive. So you'll have positive plus cos, multiply by cos, and then that is cos squared theta. And then you divide, and then you have cos, which is also cos squared theta, multiply by. So this tan 540 degrees plus theta shouldn't scare you, because what it's just telling you, if you have 540 degrees plus theta, it's actually it shows that a revolution has occurred, meaning that you went from 0 to 360 degrees and you went over again. So for you to find out by how much did you go over, so you're just going to say 540 minus 360 because you've gone beyond 360 degrees. So you'll just say 540 minus 360. So if you say 540 minus 360, you end up getting 180. So if you get 180, you will have 180 degrees plus theta. So this thing here, it's essentially equivalent to tan of 180 degrees plus theta, and then you square that. So I'm just going to rewrite everything again, I'm so sorry. And then you have cos squared theta, and then you know that tan 180 degrees plus theta, that is your second, no, not, that is your third quadrant. And you know that in your third quadrant, what is happening to your tan is positive in the third quadrant. So you'll end up having tan theta, so and then you square that, so you have -1 plus cos squared theta over cos squared theta, and then you multiply that, and then this, you're going to get tan squared theta, and then you do a little bit of simplifications again. Okay, sorry for that. You have cos squared theta over, and then cos squared theta. Remember that your tan, you can, it has like an identity, and remember that tan of theta, it's equal to sine theta over cos theta. If you square both sides, you'll have a nice identity there, which is saying tan squared of theta, it's equal to sine squared of theta over cos squared of theta. So if you substitute that in there, you're going to have sine squared theta over cos squared theta. So in your denominator, your cos squares will cancel, and after they have cancelled, you're going to have -1 plus cos squared theta over sine squared theta. So now, remember that I told you that this -1, you might need to use it again. So now it came back, so you need to use it. So from your trig identities, remember that you can have that sine squared theta plus cos squared theta, it's equal to 1. So this 1, it's basically negative, and then you have 1 inside your bracket, and then this is cos squared theta over sine squared theta. So you take the negative. So remember that your 1 is equal to sine squared theta plus cos squared theta. So you'll have sine squared theta plus cos squared theta, and then you add cos squared theta. And here you divide by the sine squared theta. So when you do that, you will have that you have to multiply, distribute negative. So you'll have negative sine squared theta minus cos squared theta plus cos squared theta, and then you divide that by sine squared theta. And then after doing that, you see that it's negative cos squared plus cos squared. So this one will cancel, and then you'll be left with negative sine squared theta over sine squared theta, which is basically -1, because the sine will cancel, so you'll end up having -1. So you see that in this case we got a value in the end.